Hi there, my name is Mitch Harlabedis, and in this video, we will see together how we can deal with one of the hottest exercises that we expect to see on the AP Pre-Calculus exams. It is titled by describing a graph. And let's see what it's all about. Let's begin with the key concept. We will be provided with some information regarding a function's monotonicity and/or concavity. We will also be given 4 possible graphs, and we will be asked to decide which one of these 4 graphs meets the given info. To begin with, let's write some of the needed theory behind all this exercise. Remember that by monotonicity, we classify a graph as increasing or decreasing. A graph is increasing as it moves upwards as we extend to the right. So this is an increasing graph. And a graph decreases as it moves, as it heads downwards as x values increase. So as we move to the right, the values of y increase, it's increasing. As we move to the right, the values of y decrease, it should be decreasing. The concavity, on the other hand, has to do with concave up or concave down. A graph is concave up, and we notate it like that, if it looks like a U shape, or if it contains a part of that U shape. Similarly, a graph is concave down if it looks entirely or partially like an upside down U shape. So let's see some examples. I will be drawing random graphs, and we will describe them in terms of monotonicity and concavity. This one is obviously increasing and concave up. This one should be decreasing and concave up. This one that I'm now drawing could be increasing and concave down because it partially looks like an upside down U shape. Remember as well that often the monotonicity goes side by side with the sign of the average rate of change in an interval. And we say that f is increasing. This means that the average rate of change is positive, and f is decreasing when the average rate of change is negative. Also, it's not only monotonicity that is related to the average rate of change, is concavity as well. But the concavity is related to the monotonicity of the average rate of change. More precisely, f is concave up when the rate of change is increasing, and f is concave down when the rate of change is decreasing. So for the previously shown graphs, we could also say that the average rate of change is positive and increasing for the first one. Or we could be saying that for the second one, that the average rate of change is negative and it's increasing. And finally, for the third one, we could be saying that the average rate of change is positive, since the function itself, the graph itself is increasing, and is decreasing. Let's see two more examples and we're done. Example number 4. Let f be an increasing function where the rate of change of f is increasing. And now I'm gonna draw 4 different graphs. 1, 2, 3, and 4. And here I will draw this, that, this, and that. Now, let's try to decode the given info. We know that f is an increasing function. So if f is an increasing function, we should directly reject the second one, b, because this shows a decreasing function, and the last one. This also shows a decreasing function. So we are between first and third. What else do we know? We know that the rate of change is increasing. So we were given some info with regards to the monotonicity of the rate of change, not about the sign of the rate of change, but to the monotonicity of the rate of change. Therefore, we were given info about the graph's concavity. A rate of change is increasing only means that the graph itself should be concave up. Which one of the first or the third presents a concave up graph? Obviously, the first one. So the right answer to this question would have been this. Let's move to one final example. Let's assume that we were given this graph, and we are also given some parts C and D. And let me put here E. Now, what we will do is describe every single change on that. Let's start with this. From A to B. From A to B, we can see that the graph is increasing, F is increasing, which means that the rate of change is positive, and it is concave down. Concave down means that the rate of change itself is decreasing. Let's change some color and describe the next part. From B to, let's assume, E. From B to E, we can see that F is decreasing, which means that the rate of change is negative, and is concave down, which means that the rate of change is decreasing. From E to, let's put it somewhere here, F. From E, let me change some color again, from E to C, it will be from E to C, F is decreasing, therefore the rate of change is negative, and it is concave up because it partially is equal to a U shape. So the rate of change is increasing. From C to F, from C to F is increasing, which means that the rate of change is positive, and it is concave up, so the rate of change is increasing. And finally, from F to D, the rate of change F is increasing, therefore the rate of change should be positive, and F is concave down, therefore the rate of change is decreasing. Be careful about this specific exercise. We expect that with regards to the multiple choice ones, this will be 1 out of 40 ones. So we should all make sure that we get that. Okay, once again, they will provide us with some info regarding the monotonicity of F and the concavity of F, or they might put it as with relates to the rate of change, whether it has a positive, negative sign, or whether it's increasing or decreasing. We will also be provided with 4 different graphs, and we will be asked to match them. That's easy. Just be careful on the concavities, monotonicities, and the relations of them with the rate of change. That's all. In case you have any questions about what you just saw, or any relevant to this topic questions in general, please don't be shy and leave them as comments below the video. As always, thank you for your time.